All right. So now that you've signed up for an account, the first thing you're going to do is start using Geogebra to take the quiz. All right. This quiz is over the 4 different types of centers of triangles. This chapter 5 in your book, starts on page 206, is called Relationships and Triangles. And want to make sure that you understand the different relationships that you'll encounter in triangles. And so you're going to have to construct some things. I figure it will be easier to construct it with the program than it would to construct with pencil and paper. I just need to know that you understand the basics of what these different relationships in triangles are. The first thing that we're going to construct is a circumcenter. We're going to construct a circumcenter, and we're going to construct a a circumscribed circle. I told y'all it was going to happen. A circumscribed circle. So the first thing we got to do is you're here. If it's not showing up, you'll click tools right here off to the side. You'll get these basic tools that are showing up. You'll scroll down, and the first thing you want to do is click more, and that'll give you all of the tools that are there. Okay, you'll scroll through the list. I'm back at the top now. You'll scroll down, you'll see basic tools, then edit, then media, then measure, then points, then construct, then lines, and then polygons. Okay, so you need to go to a polygon. Click on polygon, not regular polygon, but just click on polygon. And all of these deal with triangles, relationships and triangles. So we're going to start each one out with a triangle. Click anywhere on the screen. It'll plot your first point. You'll see a line coming out. Doesn't matter where. Click again. That'll be your second point. That's B. Click again. That'll be your third point. That's C. And what you want to do is end where you started. Click on the very first point, back on A, and that will complete this last side. And now you've got your triangle. And you'll notice that side A indicated, the lowercase letters are indicated or indicative of the fact that it's a side. So side A is opposite angle A, side B is opposite angle B, and side C is opposite angle C. So that should always be the case when you're constructing or when you're drawing or when you're diagramming triangles in math class, okay? Once you have the triangle drawn, now we have to construct our circumcenter. And the very first thing you have to understand is what a circumcenter is. And so a circumcenter, if you look on page 207, it says the perpendicular bisectors of the sides of a triangle are concurrent. That means they intersect at the circumcenter. That's a point. They intersect, or they intersect at the circumcenter, the point that is equidistant from its vertices. So we're going to construct all of the perpendicular bisectors for each side of this triangle. Okay, so we're going to come down. Actually, we're going to scroll up to construct. You'll see that you can construct a midpoint or a center. You can construct a perpendicular line, or you can construct a perpendicular bisector. We want to construct a perpendicular bisector. So click on this. You'll know you've selected it because it'll say perpendicular bisector. Select 2 points or 1 segment. We're going to select the segment. It seems to be a little bit easier. So once you've selected this, you know it's selected because it'll be in color and all the other things look a little faded. So I want to select the perpendicular bisector first for side AB. You can do whichever side first that you want. Just you'll notice that I have a regular cursor now, but as I get close to side AB, you'll notice that it turns into a finger, right? My cursor turns into a finger just like that, and then I'll left click, and it automatically constructs the perpendicular bisector. Line F is the perpendicular bisector of AB. All right, I want to do the same thing. I'm still selected on perpendicular bisector. I want to do the perpendicular bisector for line AC. I just click anywhere, and it's got it. Then I'll click anywhere on this side over here, and it has constructed it. And notice that all 3 perpendicular bisectors are concurrent at a single point. And by the definition of the circumcenter theorem, it says that the point where the perpendicular bisectors are concurrent is called the circumcenter. That's this point right here. We want to label that point. So go all the way back up in your tools. Go all the way back up and select point. Okay, and you're going to left click at the point of concurrency or the point of intersection right there, and you'll notice that it has labeled that point D. I want to actually call it the circumcenter, so I'm going to put my finger over the point and right click. This box comes up, and I'm going to go to settings. The name is D. I want to keep that the same, but I want to give it a caption, and that's going to be the circumcenter. I want it to be the circumcenter. Then I'll hit enter, and then I'll hit the X to get rid of that screen, and you'll see that now it is the circumcenter, right? And you can move. You can come up to the move tool and drag, and you can see that the circumcenter can be inside the triangle. There is a place to where you can drag it, and it would be the circumcenter would be outside of the triangle. So you need to know that the circumcenter can be either inside the triangle or outside the triangle. You also need to know that the circumcenter is it is made up of perpendicular bisectors. It is the place where the perpendicular bisectors meet. Okay, so what I want you to do is you're here on this screen, and I want you to hang on one second. I want you to come to media. Here it is. Come to media and go to text. Click on text, and I want you to just click anywhere here. When you click out in space, it'll come up with a text box. I want you to make a note of this. You don't need the advanced for anything. So here, I want you to say, this is what I want you to say. You're going to make a note of your findings. The circumcenter can be either, I don't have to say either, can be inside or outside of the triangle. Okay, once you type that, you're going to click OK, and you see it right there. If you want, you can drag it in the screen. You can make the screen smaller. You can make the text smaller if you want to. Let's make it, it's small now. Let's make it very small. Doesn't matter. All right. So there it is right there. Now you're going to do the same thing again. Go down to media, click text. And you're going to type another finding that you have discovered. And not that you should already know this, but you're just going to click anywhere here. It'll come up with this. And you're going to say, here's what you're going to say. The circumcenter is the point where this is the important part, perpendicular bisectors meet. Okay, click OK. Just so you don't have to change everything. Let's go back. Let's click that one, and I think is there a way, instead of making it very small, let's just keep it at small. That way you don't have to change them all. Okay, and just drag them maybe somewhere down here, somewhere under. To select it, just right click and drag. There we go. Now they're there. Now remember, we don't need those right now. I'll scroll out and I expect to see them somewhere, but for now we don't need them in the screen. Okay. Remember what our circumcenter theorem said. It said that the circumcenter is the point that is equidistant from each vertex. Okay, so that means from the circumcenter here to A is the same distance as from the circumcenter to C and the circumcenter to B. Now we got to prove that. Here's how we're going to do that. We're going to create a segment from the circumcenter to each vertex. So come over here and you're going to look at lines. You're going to come under lines. You're going to click segment. Click segment, and it says select 2 points. So we're going to click on the circumcenter, and we're going to click on the vertex from the circumcenter to A. You can see that it labeled it point I right there. If I right click on I can go to settings, and I want you to do this, change the color to red, and change the style, go to the style tab and change the line style to a dashed line. And then close that, and you can see that now it's a red dashed line called line I. You're going to do the same thing. You're still selected on the segment. You're going to click the circumcenter and point B. Right click on J. Here you see it named at point J. Right click on J. Go to settings, and you're going to change the color to red. Come under style and change the line style to dashed. Close that. You see it did the same thing again. Make it smaller if you need to. Do the same thing one more time from the circumcenter to point C. Then it's called it point K. Right click on that point K. Go to settings. Click on the color tab. Change the color to red. Click on the style tab and change the line style to a dashed line. Close this out, and you can see that it has given me dashed lines all the way around. That's important for you to do. It's part of the process. Lastly, we said we had to prove that all these lines were congruent, or they all had the same measure. So here's what I want you to do. Pay attention. You're going to scroll up until you see the measure category, and we're going to measure distance or length of each of these lines. So click on that, and it says select 2 points. So we're going to select the circumcenter and A. That's the thing that we want to measure. Notice that it's got it as 4.3. Okay. If you see this, the distance from D to A is 4.3. Right click on this, go to settings, right click it and go to settings, go to position, and click that box, absolute position on screen. Okay, close this out, and then you can right click on this, drag it off to the side, and you can put it over here. Now here's what I want you to do. Yours may have a lot more decimals than mine. If you right click and go to settings, then you click this gear icon here, you can round it to 2 decimal places. Okay, round it to 2 decimal places, click the X, and you can see if I were to come up to my move tool and move this, you can see that it has rounded it to 2 decimal places. Sometimes it only shows 1, sometimes it shows 2. It depends on where I stop it at. Okay, so we've measured from D to A. We're going to come back to measure, click on distance or length, left click on it, and go from the circumcenter instead of to A. Now we're going to go to B. Okay, and you can see that it's measured from DB now. Right click on the box that's got the measurement in there, go to settings, go to position, and check that box. Okay, if it has more than 2 decimals, you want to come here around to 2 decimal places again, click save settings, and close that. Now you can right click and drag this off to the side. Okay, you want to line them up nice and neat there, and we have to do it one more time. Distance or length is still selected. Click on my circumcenter. This time I'm going to C, DC. Click on that, right click the box, go to settings, go to position, and then check that box. If it's not rounded, come to here, change it to 2 decimal places, save settings, and close. Now I can right click on this and line it up over here in the general area. Now, we proved that they are the same. Now, for further proof, we can come to our move tool and we can start moving these vertices around. If I move point B around, I can see that they all change, but they all stay the same, right? That's how you know you've done this correctly, is when you move this around, your circumcenter stays as the point of intersection between the 3 perpendicular bisectors, and you notice that the distance from the circumcenter to each vertex is the same. So we need to make note of that finding. Come down to media, go to text, and click anywhere. Maybe scroll out and find where your other stuff is. Click down here, and you're going to say the distance from the circumcenter to each vertex is the same. Of course, the book uses the term equidistant. If you want to use that, that's fine. Once you type that out, click OK, and you have it there. If you want to drag it, you can right click on the statement to kind of line them up a little bit, and it should look a little bit neater. Go to the move tool, and you can get rid of the boxes around there when you select the move tool. And there you have it. You should have all of your findings here. You should have all of your measurements over here. And then when I zoom in, I should be able to do that and see everything. All right. There you go. Next video will be how to save this and send it to me. So as soon as you finish this, watch the next video.